Hey everybody, we're going to take a little bit of time today and we're going to learn about percent composition. So let's start off here where we deal with percent composition, and let me get rid of this calculator. Percent composition, there's a lot of different ways we can express percent composition, but what we have to realize is that percent composition is based on the fact that compounds will always have the same elements combined in the same ratio by mass. Okay, so the example that I always have, not that I always have, but an example is like carbon dioxide, CO2. Okay, carbon there'll always be one of them. In oxygen, there'll always be two of them. So if we assume 1 mole, which we don't have to, but if we do for this example, we'll notice that the ratio is going to be 12.011, which is the molar mass of carbon, to a ratio of 31.999, right? Which is the molar mass of oxygen times 2. So what this does is this gives us 3 different ways to express the composition. And so we can express the composition as a ratio of the number of atoms, and we can express this as a ratio of the masses, or if we really wanted to, we could figure out the percent of the total. So this is, 12 over 12. Carbon is 12. The total is 44, so 12 over 44 gives us a percent. So that's what we're talking about here when we are dealing with percent composition. And we do this with a process called chemical analysis. There's a whole bunch of people in the world that do chemical analysis, and that's their only job. And it's very interesting. I did it myself when I was in graduate school to determine formulas of compounds that I made. So it's pretty cool. And so here's some examples. Okay, another example using ammonia. Okay, in 1 mole of ammonia, again, this could be 2, 5, 10, 20, a half, a tenth of a mole, whatever. The idea is that ratio is 1 mole of nitrogen to 3 hydrogen. Okay, in 1 mole of ammonia, there's 1 mole of nitrogen and 3 moles of hydrogen. Okay, and the same thing here that we did before. So we looked, and I took nitrogen. There's only 1 nitrogen. That's the mass of nitrogen. And I took hydrogen. The molar mass of hydrogen is 1.0794. And then I multiplied it by 3 to get this. And this gives us another ratio that you can use. And then lastly, I figured out the percentage. If I find the overall mass and then figure out the percentage of nitrogen, notice that this percentage is consistent. The point of all of this is that what you can do is you can take the percentages eventually and work backwards to find the formula. But before we do that, let's go and figure out this. Okay, so it says, what is the mass percent of each element in propane, C3H8? And then it asks for the mass of carbon contained in that many grams. So here's what we're going to do. We know that the formula is C3H8. I am going to set this up to find out what the mass of carbon is and the mass of hydrogen. So to do that, we need the molar mass, or we need a total mass. So there's 3 carbons times 12.011. Oops. Sorry, didn't mean to do that. And for hydrogens, there's 8 of them times 1.00794. So now I have my calculator out, so I'm going to go 3 times 12.011, and that's going to equal 36.033, and then we're going to go 8 times 1.00794, and that's going to be 8.06352. Now we're going to add those up. Plus 36.033. Okay, that equals 44.09652. Okay, so this is our total mass. Now, to find the percent of carbon, you take the part that's carbon, part over the whole here. Let's see. So we're going to go part. The part is 36.033, and the whole thing weighs 44.09652. And so I'm going to take 36.033, I'm going to divide it by that answer, and then I'm going to multiply it by 100 times 100. And that gives us a percentage of 81.71%. And so that now means that the percent hydrogen for this, you could do this one of two ways. You could do the same process. You could do 8.06352 over 44.09652 times 100. Or you could take this and subtract it from 100 to get 19.29%. So, and then we always put the element the element symbol afterwards. That way we know it's percent carbon and percent hydrogen. Okay, so I did this by going 100 by taking 100 and subtracting 81.71. Okay, and then oh look, see, I'm glad that I checked that out because I messed up my simple math. Okay, but now it says, what is the percent of carbon contained in 454 grams of propane? Well, this now tells us how many grams of propane we have, and we know that every sample of propane has 81.71 grams of carbon. So, to figure this out, I'm going to make a little space here. I'm going to erase this. So, to figure this out, we're going to do something pretty straightforward. We're going to go 454 grams. We're going to multiply it by 81.71% because we know that 81.71%, and when we do this we use the fraction, so I kind of call it the fractional percent because we don't ever take the math of the percent, we actually have to convert it to that. And so now we go 454 times 71%. So that means that there's 370.96 grams of carbon in this sample. So this shows us both ways on how this works. Okay. So this is kind of the more straightforward way of doing percent composition. The more exciting part is when we do it backwards. But that's this. Have a great day.